Welcome back to COBOL for the mainframe. In this episode, we will start to look at how files and storage are handled in COBOL. To do this, we will build a simple program to create a sequential or flat file with very basic records. From there, we will review the layout of the records and how they are defined. For this exercise, we will use a program called Program1. You can see that name in the program ID statement on line 2. This simple program will move some values to work areas on a record and then write the record to a file. The values are hard-coded in the program, so it's not useful for any purpose other than to explain how basic storage and files work. Moving down in the program a bit, you see the area called File Control in the Input-Output section. The select statement is where we define the output file to the system, meaning how the file will be referenced by the job running the program. In this case, we are using DD1, but you see it defined as UTS-DD1. The prefixes may seem a bit dated, but the UT stands for utility, specifying tape or disk. The S means QSAM, or Queued Sequential Access Method. All this means is a flat or sequential file. Next, you see the file defined under the File section using the name OutFile. This name is how the file is referenced in the program and where we define the basic layout of the records. You can see that each record contains 88 characters, or bytes. For our example, we will keep the block size the same as the record size. The block size is used to make reading files more efficient and can be very important when using large files. You also see the data record is defined in an area called Record Area. This is where the records are defined into individual fields. Moving down a little more, we can focus on the record area. Here you see the fields we will move data to before writing a record to a file. COBOL uses levels to define storage areas. The first level you see here is 01 for the entire record area. This is broken down into 03 level areas for the fields defined under record area. Later, you will see other levels defined as we need to break down fields into other areas or use work areas in the working storage section. Much more on that later. For now, let's focus on our basic record and the fields defined here. You see the field name, such as record ID, and next to it is what we call the PIC, or field definition. The PIC tells COBOL what type of storage to define for the field. This can get very complex, so we will start with some of the most commonly used values. On the field's record ID, first name and last name, note the PIC starts with an X. This means the field is alphanumeric and can contain any character. The number in parentheses to the right of the X signifies the length of the field. In this example, record ID is 2 characters in length. Account number is defined using a PIC of 9. This means the field is numeric. It has no decimal place defined and has a length of 10. This field can store a value from 0 to 9,999,999,999. This field can also be used in calculations, where fields defined with a X can't without causing problems. The last 2 fields we have defined are account balance and packed balance. The PIC definitions for these two are a bit more complicated. For account balance, notice the S at the start of the PIC. This signifies the field has a sign, meaning it is explicitly positive or negative. You also see a V character after the length of 15 specified in parentheses. The V means virtual decimal and allows definition of digits after the decimal. In this field, we have 2 places after the decimal for tenths and hundredths. The final field, packed balance, is the same as account balance except for the comp3 notation after the definition. This tells COBOL the field is packed to allow the field to take less storage. Once we create the file, it will be displayed so you can see the differences in unpacked numeric and packed numeric fields. Alphanumeric fields cannot be packed for reasons that will be clear when the file is displayed. Further down under Working Storage section, you can see one area defined as record count. The 77 level is commonly used for counters or indicators. Remember, the Working Storage section is not part of the record area and is independent of the file that will be written. When you see value 0 on a definition, that means the field has an initial value of 0. Moving on down to the procedure division and the main logic, we will focus on the part of the code that moves the values to the defined fields and writes the record. A detailed explanation of how the logic works will be part of the next episode when we get more into procedure division. The 200 process paragraph is where the values are moved. At this point in the program, the file has been opened and we are ready to create a record. You see the hard-coded values being moved to the respective fields followed by a write sentence. This is followed by adding 1 to the record count defined in working storage under the 77 level. After this, the file is closed and the value for record count is displayed in the job and the program ends. Once a program has been written, it must be run through a compile and link edit. The compiler checks the program source for syntactical errors, meaning statements that need to be corrected or items that are missing. If the program compiles cleanly, the link edit step creates an executable module in a library. The member you see here is Job Control Language, or JCL. Please don't be overwhelmed by how this looks. It will be explained in detail later. Just know that all programs have to go through this before they can run. You can download this sample by using the link provided below. Once we have a good compile and link edit, our program can be executed by using another set of JCL. Again, don't be worried yet about what everything in JCL means. We will get to that, and you will see it's actually very straightforward. You can probably even tell what's going on in this simple job. The file a12345.test.file is deleted. Then our program 1 is executed to create the file. From here, go back to the command line, type sub, and hit enter to execute the job. Now hit F3 until you get back to the utility selection menu and select option 8 for outlist. Tab down to the last entry on the screen called test job. Put an S there and hit enter to display it. From here, enter M on the command line and press F8 to go to the bottom of the listing. At the very end of the display, you can see our record count that was displayed by the program showing 1 record written. To see the file we created, hit F3 back to the utility selection menu and type equals 3.4 and hit enter twice. Tab down to the file we created. Type E then enter to bring up the record. What you are looking at here is called a hex display of the record we created. Hex means hexadecimal, and it uses base 16 instead of decimal, which uses base 10. This means that each part of a byte can be represented by 0 through F. A character has 2 zones on the mainframe. You can see that for our record type of AA in the first 2 bytes, the upper zone is C while the lower zone is 1. This is the EBCDIC representation of the letter A. The mainframe uses EBCDIC instead of ASCII. If you are accustomed to PC or server programming, this will be an adjustment. It shouldn't be too difficult to make out each individual field. You can see the AA then the account number. The first name Joe takes 25 bytes, so there are 22 spaces after the E, represented by the EBCDIC 40 for a space. This is followed by Johnson and then 18 spaces. Hit the F11 key to move to the right in the record, and you can see the balance fields. Remember we said one is signed and unpacked and the other is signed and packed? Look closely, and you can see the differences. On the signed unpacked field, it takes 17 full bytes. The last byte may be a little confusing if you think it should be a 9. It also contains the sign of plus. The mainframe adds the sign to the last byte for numeric fields. Now notice the signed and packed version at the end of the record. It only takes 9 bytes since it doesn't need the wasted F in the upper zone for numeric. The F is not needed since numeric is only 0 to 9 and can be half a byte. Where the unpacked version takes 2 bytes to represent 00, packed can do it in 1. Also notice the sign on the end. For packed, the sign will be the last half byte. Incidentally, a half byte can be referred to as a nibble. We have covered a lot of ground here, but you should have a basic understanding of how data and files are used in COBOL. This concludes this episode. Please remember to like the video if it helped you, and also please subscribe to the channel so we can continue. Don't forget, use the links below to download the program and JCL we used today and email any and all questions to the email shown. If you prefer, simply leave a comment and we will try to answer any questions. Thanks for watching, and we will be back soon to go further into using COBOL on the mainframe.